Good day, everybody. I am Rosamia Sanchez, and this is another topic, Chapter 10, Utilization of Assessment Data. Before proceeding to my report, I would like to introduce to you my co-reporters. Starting with Geraldine Tumatal will be next to me, and then Christina Kagatan. So at the end of this chapter, you are able to understand meaning to test results using norm reference and criterion reference interpretation. So let me start the discussion with a question of what comes to your mind when you are taking a test? Well, the first thing that comes to our mind when taking a test is what will be our score, right? That is a normal way of asking, even in ourselves as a student. And this will be asked also as a future educator. This will be asked also by our students. That is why it's very important to really know what's the role of test in as a form of assessment. Because as we have learned in section 1, tests are forms of assessment. They are administered to collect data about student learning, and then test results can aid in making informed decisions to improve curriculum and instruction. So even not just in school, or any other kind of field that we are, for example, in sports, so naa dyan mga tests, para i-assess pa kung unsa ang ato ang performance, kung unsa ato ang outcome learning at the end of the session or lesson. So, in this chapter, we shall look into the types of test scores. Do you have any idea what type of test scores are there? Yes. Okay, so don't worry because me and my other co-reporters will explain to you and understand you for you to understand, and to use it in the future. Okay. Okay. So now, what does the score mean? So unsa man jud ay pasabot ana niya, no? So may pulos. No, unsay essential ba nganong makabalot ta sa score? So, test scores interpretation are vital not just for the students concerned but also for the parents, right? So, dili lang man ang estudyante lang naghihuna-huna pod aning score, no? Kay even the parents themselves mangutana biya pod sila sa score sa ilang estudyante. Kung maayo ba ang ilang performance sa school, no? Perfect ba sila? Dako ba sila score kada test? Sinana ba? Kaya nga naman, ang using ay kanang ang pag-test magod sa mga estudyante mo na siya nag-measure nga if naminaw jud ang bata, no? If naminaw ang bata sa mga discussions and everything, and then by the end of the day, makakuha siya og nindot pod nga score, no? For example, a pupil who received an overall score in the 16th percentile in mathematics would place the learner in the average group. The child's performance is as good or better than 60% of the students in the group. A closer look into the sub-skills scores of pupil can help teachers and parents in identifying problem areas. For example, a child may be good in addition or in subtraction, but he or she may be struggling with multiplication and division. So, I myself before, or I can tell if until now, no, magliso jud ko aning multiplication or division, no, sa una sa elementary. I only know, not really master or not really kanang ano jud sa buhong jud sa addition subtraction, but at least ba makabalo ko. But then when it comes to multiplication and division, dili na ako kabalo. So kita nakarelate ani guys. Okay ra na guys, kay dili ra mo nag-iisa. Marami tayo dito. Okay, so so at this slide, no, you can see there are types of test scores. The raw and percentage scores, percentile rank, and the standard score. So um, the first one is the raw and percentage scores. So definition, from its description, raw scores are obtained by simply counting the number of correct responses in a test following the scoring direction. To give you an example, no, a student who gets 30 of 50 items in a math test and correctly obviously gets a raw score of 30 because what lang siya 30. This means the student was able to answer 60% of the items accurately, which is the percentage score. So nganong nahimo man siya 60%. So if um mahibal na to kung pila percentage sa scores if ang raw score is imuha siyang i-divide into um the total number of the items and then ang result ato is i-times nimo siya into 100%. So 30 divided by, so in this case 30 divided by 50 pila, di ba? And then 30 divided by, oh yeah, 30 divided by 50 and then multiply it into 100, so the result is 60. And the percentage score is useful in describing a student's performance based on a criterion. However, the problem with the raw and percentage score is that they do not provide adequate information about student performance. They do not take into consideration the average score, so kung unsay average score or the mean score of those who took the test and how dispersed the scores are, or the standard deviation. That's why this is the reasons why raw scores are oftentimes converted to another score type. So I'm going to show you the example here, which is natabunan siya sa kunaw. Okay, mo ni siya. Okay. So mo ni siya. Wait lang ha. So from this example, kani nakakuha siya og 28 over 50. So gi-divide niya into ang 28 given 50 then you multiply niya 100, so ang result is 56%. So mo na siya percentage score. So do you get it now what raw and percentage scores are? So there are two types of derived scores, no? First one is the scores of relative standing and developmental scores. So examples of the first type are percentiles, standard scores, and stanines, while developmental scores include grade and age equivalent. Okay, so as I mentioned earlier, a standard score is derived score which utilizes the normal curve to show how a student's performance compares with the distribution of scores above and below the arithmetic mean. Among the standard scores are the z-score, t-score, and stanine. Okay, so this picture shows or represents or shows the normal distribution and scale. So the normal curve that you can see, it represents the normal distributions, or also known as a symmetric theoretical distribution. Okay, as you can see from the earlier slide, now the mean or the average median, or the mean or the average median, which is in the middle score, and mode is most frequent score, or kasagara ni siya score, are all located at the center peak of the bell curve. Since the mean and median are in the middle, half of the scores are below the mean and half are above it. So another one is the empirical rule, 68, 95, 97.7 rule shows the connection between the normal distribution and the standard deviation. It states that 68% of the scores will fall within one standard deviation of the mean, 95% of the scores within two standard deviations, and almost 99.7% of the standard scores will fall within three standard deviations of the mean. Refer to Pierre Whitman. Okay, so in terms of performance, the middle or the 68% of the normal distribution from the example is average. No? Kung makakuha daw ka og 68%, then it's average. It belongs to the average. The top and the bottom, 16%, are considered high and low performance. That's why the normal distribution approximates many natural phenomena. However, to insist that educational achievement outcomes are normally distributed as well would be a mistake. And the distribution of test scores is also contingent on the assessment procedures according to Netco and Brookhart 2011. The difficulty of test items can alter the shape of the distribution. So, kung unsa kalisod ang test, maka-alter po siya sa score distribution. Okay, so I hope that you have learned something from this part. And the following topic will be further discussed by the next reporter, Ms. Geraldine.
Good day everyone, I am Geraldine Tumatal and this is the continuation of Rosamia's report about the utilization of assessment data. Z-score. The Z-score gives the number of standard deviation of a test score above or below the mean. So the formula is Z is equal to X minus black X over S, where X is the test score, black X is the average score, and S is the standard deviation. So a negative Z-score means it is below the average, while a positive Z value means it is above the average. For example is, in a 50-item math test where the mean is 25 and the standard deviation is 10, a score of 35 has a Z-score of 1, which means that it is one standard deviation above the mean. So it is obvious that the student's score belongs to the upper 50% of the norm group. To be more specific, we can determine the percentile rank equivalent to a Z-score of 1. We can check using a normal table or by looking at the normal curve. So Z-scores can be negative, indicating values below the mean. They offer critical insights into the relative position and significance of individual data points, enhancing our ability to analyze and interpret data effectively. So next is the T-score. As I mentioned earlier, the Z-score have negative values or numbers. So some teachers are not comfortable with using Z-scores because of negative numbers. For example, a score of 12 in a 20-item science test with an arithmetic average of 15 and standard deviation of 2 yields a score of negative 1.5, but the student or his or her parents may not fully comprehend why it is negative. More so, it may adversely affect students' motivation. So to fix this, we can translate it of percentile rank using the normal table or convert the Z-score to a scale that does not include negative values like the T-score. So in a T-score scale, the mean is set to 50 instead of 0 and the standard deviation is 10. So to transform a Z-score to a T-score, we multiply the Z-score by 10 and add 50. So the formula is T is equal to 10Z plus 50. A score of negative 1.5 converts to a T-score of 35. Hence, similar to a Z-score, a T-score of 35 indicates that the row score of 12 is 1.5, standard deviation below the mean. So this implies that based on the test scores, the student's performance below the average. T-scores offer a valuable alternative to a Z-scores, particularly in educational setting where negative values may hinder comprehension and potentially impact students' motivation. So the use of T-score can foster a clearer understanding of assessment results among students, parents, and educators. This is the STA9. So STA9, short for Standard 9, is a method of scaling scores on a 9-point scale. So a row score is converted to a whole number from low 1 to a high 9, unlike the z-score, where the mean and standard deviation are 0 and 1, respectively. STA9s have a mean of 5 and standard deviation of 2. So STA9 scores of 1, 2, and 3 are below average, 4, 5, and 6 are the average, 7, 8, and 9 are above average. So in a previous example, the STA9 equivalent of a row score of 12 is 2. This can be calculated from the z-score by multiplying it by 2 and adding 5. So the formula is STA9 is equal to 2z plus 5. So a STA9 value of 2 shows that the student's performance level is below average. So the problem with STA9 is that they are not entirely precise. A student with a STA9 score of 2 may have a percentile score of anywhere from the 4th to 10th. To show the significant difference between two scores, there should be at least one STA9 score between them. STA9s provide a simplified 9-level scale for evaluating performance, offering a broad categorization of score relative to average. While less precise than the z-scores or percentile ranks, they provide an accessible method for quickly classifying performance into below average, average, and above average ranges, making them useful for general assessment and communication. This table, or table 10.1, standard score equivalent and percentile. So as we can see here, we can see the difference between the z-score, t-score, percentile rank, and the STA9. Next is the normal curve equivalent. The normal curve equivalent, or NCE, is the normalized standard score within the range 1 to 99. It has a mean of 50 and standard deviation of 21.06. Caution should be exercised when converting a row score to NCE because the latter requires a representative national sample. So NCE is preferred by some because of its equal interval quality. So score differences between tests and among sub-tests in a test battery can be calculated and examined. For example, is an NCE of 30 in reading is twice as far from the mean compared to an NCE of 40 in mathematics. So the student's score in mathematics was 10 points higher than in reading, but both are still below the average of score 50. Standardization allows for comparison of scores across different tests and subtests, offering insights into relative performance. While NCE scores are considered equal interval, caution is necessary when converting row score to NCE to ensure the reference sample is nationality representative, thus maintaining the validity of the assessment. Lastly, for my report is about the developmental scores. So a grade equivalent, or GE, describes a learner developmental growth. It gives a picture as to where he or she is on the achievement continuum. For example, if a second grader obtained a grade equivalent to 4.2 in language mechanics, it means that his or her score is typical of a fourth grader 2 months into instruction. Note that the GE is an estimate of a learner location in the development. Grade equivalent score provide a straightforward way to gauge a student's developmental growth by comparing their performance to that of students in different grades. While these scores offer general sense of students' achievement level, it's important to remember that they are estimate and should be interpreted with caution, considering individual students' differences and the specifics of the assessment.
Good morning, everyone. I am Christina Bernadette A. Kagatan, your third reporter for this chapter.
Our lesson for today is about the types of test score interpretations. But before we dig deeper into our main topic, let us first imagine that there are two students. These two students both scored 40 out of 50 on the exam. The first student's score is compared to her classmates. If she's in the top 10, it means she performed better than the most of them. The focus is on ranking and comparison with others. While the second student's score is compared to the learning objectives. A score of 40 out of 50 means she mastered 80% of the skills taught. The focus is on what she actually learned, not on how others did. So even though both students had the same score, the meaning changes depending on the frame of reference we use. This is what American psychologist Robert Glaser explained back in 1963 when he introduced the two major ways of understanding test scores, the norm reference and the criterion reference interpretation. Let's begin with the norm reference interpretation. The word norm comes from the Latin word norma, which means rule. In this interpretation, a student's score is compared to the performance of other students in the group. For example, you took a test and scored 67 out of 70. When the teacher compared everyone's score, your score was the highest in the class. This shows your performance is judged by how well you did compared to your classmates. The purpose here is ranking to find out who is above average, average, or below average. This is used in standardized aptitude and achievement tests, placement exams, and even when selecting students for competition. Apart from school average norm, there are also other types of norm. This is the international, national, local, and special norm group. First one is the international norm group. In the international norm group, the scores are compared against students from many countries across the world. It's often applied in a large-scale international assessment. Example of this is the PISA or the Program for International Student Assessment. A student's score in reading or math is compared with the performance of students of the same age from over 70 participating countries. The second one is the national norm group. In the national norm group, the scores are compared with test takers across an entire country. This is common in national standardized tests used to measure how students in one country perform relative to one another. Example of this in the Philippines is the National Achievement Test or NAT. A grade 6 student's score can be compared with the performance of all grade 6 students nationwide. The third one is the local norm group. In the local norm group, the scores are compared with a smaller, more specific group such as student in province, city, district, or even a single school. It is helpful for teachers and school to see how their learners compared with peers in the same environment. An example of this is a science quiz where a student's score is compared only with the other grade 10 students in the same district, not the entire county. The last one is the special norm group. In this group, the scores are compared with the test takers who share special characteristics or conditions. This ensures fairness when evaluating learners with particular needs. Example of this is a reading test for visually impaired students where scores are compared only with other visually impaired learners. Expert Nitko and Brookhart remind teachers to be careful with interpreting test scores. They suggest that first we need to watch out for unusual or extreme scores because they may not always reflect the student's true ability. Sometimes, a very low or very high score can be caused by other factors, like the student being sick, nervous, distracted, or even guessing the answers. Number 2, look for reason why a student may be underperforming, because low score may be caused by learning difficulties, lack of motivation, or even personal problems. Number 3, don't expect surprises for every student, because teachers should always know how most students are performing in class. A score that is totally unexpected may signal something unusual. Number 4, small differences may just be chance. because a few points higher or lower might not always really mean a big difference in ability. It could just be a normal test variation. And lastly, use other information, not just one test, to explain performance. Why? Because one test cannot capture everything about a student's learning. Teachers should also consider classwork, projects, and observations for a fair judgment. Now, let's move on to criterion reference interpretation. The word criterion comes from the Greek word kriterion, meaning standard. Here, a student's score is compared to a fixed set of standards, not to other students. For example, in a driving test, it doesn't matter if you scored better than other drivers. What matters the most is whether you pass or meet the criteria that they set. While in the school settings, when a teacher says, you mastered 50% of lesson objectives, that's a criterion reference. It's about what you can do or cannot do, not how you compare to others. Reference is widely used in licensure exams. Teacher-made mastery tests, skills assessment, and performance tasks. Here, many students can pass together if they all met the standard. Many can fail together if they don't. The focus is mastery, not ranking. So in short, criterion reference interpretation answers the question, did I meet the standard or not?
And that's all for my report. Thanks for watching.